Hello everyone. In this video, we are going to look at how to develop different types of box plots. A simple box plot, a box plot with different conditions. We are going to be using Seaborn and Matplotlib. Seaborn is a wonderful library that helps us to create different types of box plots very easy. But before seeing the visualization, let's understand the concept of box plot. Box plot helps us to visualize the distribution. That is first point. The second point is it helps us to identify outliers. That is the biggest benefit of box plot. Box plot, because it helps us to identify outliers, is used extensively in the world of fraud detection because frauds are outliers, right? It is used in the world of predictive maintenance. You want to identify data points that indicate failure points in a factory operation. So there are a lot of applications for outliers. When you identify outliers, you can use it to understand or analyze why you are having outliers and thereby improve the process also. So box plots have got a lot of benefits. Uh, to compute box plot, you first need to identify the midpoint, which is the 50th percentile point. When you arrange your data set either in ascending order or descending order, the midpoint is the median. Okay, that is as far as the concept of understanding the middle data point. You also need to find out what is the 25th percentile and 75th percentile. Percentile differs from percentage. When you say percentile, you mean that so many data points are below that particular percentile. If you say 25th percentile, 25% of the data points are below that particular data point, right? 75th percentile means 75% of data points are below that particular data point. That is the concept of percentiles, right? It is different from percentages. Please note that. So to identify outliers, we use this formula Q1 minus 1.5 times Q3 minus Q1. Okay. And Q3 plus 1.5 times Q3 minus Q1. So any data point below this or any data point beyond this is known as an outlier. You can then take this outlier point and analyze why you are having outlier and take necessary action. So the Seaborn library or Matplotlib library computes these percentiles and interquartile range and plots the graphs automatically. You don't have to do any computation. I'm sharing this so you understand this concept and you can apply this concept in real life. Okay, so now let's get into the visualization part of it. I'm going to be using this data set where there is age, sex, BMI or body mass index, number of children, whether the individual is smoker or not, region, and what are the insurance charges. Okay, so this is the data set I'm going to be using. Here you can also observe that charges is the output variable or Y, and age, sex, BMI, children, smoker, and region are X's. So charges depend on age, sex, BMI, children, smoker, and region. Okay. We are going to be using Google Colab as the development environment. The first step is to connect. Let's click that and we wait for the green tick mark to appear. Okay. It is initializing and it is connected. You can see this green tick mark. The first step is let's import NumPy and Pandas. Okay. And we use these two lines of code to connect the Colab development environment and the place where the file or the data set is stored. I have stored the data set in Google Drive. So I am going to establish a connection between Colab development environment and Google Drive. Okay. So when I click this, it will ask me to connect. Let's select the email ID and let's give access so that the connectivity is established. Okay. Now let's read the file. The name of the file is insurance multiple regression. Let's read the file, and I will store that in the data frame data1. Okay. Now let's import Seaborn and Matplotlib. I'm going to start with a simple box plot using Matplotlib. Okay. Let's click this only for charges. I'm going to be creating a box plot. See this? We have a simple box plot. All these are outlier data points. Now let's create another box plot where two variables are at play. Okay. So here if you see, I created a box plot with just charges. I'm going to create a box plot with BMI and age. Okay. You see here, first I'm defining BMI age and then creating a box plot. Right? So if you see, in the case of BMI, you have many outliers, whereas in the case of age, you don't have any outlier data points. Right? So now let's make use of Seaborn and create a box plot for all the variables which are numeric in nature. Okay. Obviously, we can't create a box plot when non-numeric data is there. Instead of defining like this, in my data set, I have certain variables which are numeric. So for all those variables, I want to create a box plot. So I'm using Seaborn. Okay. Let's click this. And we have the box plot for charges, age, BMI, and children. Of course, the scale is not proportional here, which is why the box plot for age, BMI, and children are not visible clearly. Okay. Now let's see a couple of more box plots. Here I am looking at box plots for region and charges. I am also want to slice this data for smokers and non-smokers. Let's see how the result looks like. Let's run this. Look at this graph. You have box plots for different regions corresponding to charges. Okay. And you are seeing the box plot for smokers and non-smokers. If you see, in the case of smokers, you don't have any outliers. Whereas in the case of non-smokers, you have many outliers. This indicates that other factors are at play. This is very cool, right? This way of representing box plots. Okay. So the concept I use is hue equals smoker. That's all. Okay. I can also consider hue as say 6. Maybe the charges differ for male and female corresponding to different regions. You can play around like this. Okay. If you choose dodge equals false, the box plots will appear one below the other for each of the regions. That is the only thing. Okay. You won't be able to see the outliers clearly. Whereas when you choose dodge equals to, you can see the outliers clearly. Okay. Now let's run another variant here. Okay. Another type of box plot. If you see here, we get to see the distribution of all the data points here. So I use swarm plot on top of box plot. That's all I'm doing. If I use only this box plot, I will not have this distribution shown. By looking at this, I can clearly see how my data points are distributed. This is a wonderful advantage, right? Here I get to see the outliers. Here I get to see how my data points are distributed. Isn't that wonderful? So here I am actually combining two different type of charts because I want to look at data in a different fashion. Okay. Now let's look at one more type of box plot. Here I am looking at two conditions, right? Smoker and sex. Of course, I am looking at region and charges only, but I am introducing or looking at the box plot from the perspective of smoker versus non-smoker and male versus female. Let's see how it looks. Let's run this. See this? In a single visual, this is like two graphs are there, but in a single visual, I get to see how the box plot for charges and region is there for male and female and smokers versus non-smokers. This is even better, right? Very rich graphs are available that make our lives a lot easier for data analysis. Okay,